Hello students, today we will do physical and chemical equilibrium question part 1. Disclaimer, the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathee@itk.ac.in and we shall remove the images. In this session, we will be practicing questions from 1 to 8. Question says that in a chemical reaction, the rate constant for the forward reaction is 7.5 into 10 to the power minus 4 and the equilibrium constant is 1.5. The rate constant for the forward reaction is A. Option says that 5 into 10 to the power minus 4, B. 2 into 10 to the power minus 3, C. 1.125 into 10 to the power minus 3 and D. 9 into 10 to the power minus 4. So your time to solve this question starts now. Your time is up. In this question, we are given a chemical reaction whose rate constant for the forward reaction is given as 7.5 into 10 to the power minus 4. And the equilibrium constant is also given. Now you have to find the rate constant for the forward reaction. Very simple question. So the correct answer will be C. We know that the equilibrium constant K can be written as the rate constant for forward reaction divided by the rate constant to the backward reaction. Means the ratio of these two is equals to the equilibrium constant. If you put the values of K, which is 1.5, Kb, which is 7.5 into 10 to the power minus 4, we can get the value of Kf easily. So we get Kf is equals to 1.25 into 10 to the power minus 3. Next question, 56 gram of N2 and 6 gram of H2 were kept in 400 degrees Celsius at in a 1 liter vessel. The equilibrium mixture contains 27.54 gram of NH3. The approximate value of Kc for the above reaction in mole raised to the power minus 2 liter square is, options are A 12.8, B 11.9, C 14.8 and D 0.8. So your time to solve this question starts now. Your time is up. So in this question, we are said that we are taking N2 gas, that is nitrogen gas, 56 gram and hydrogen gas 6 gram in a 1 liter vessel, right? And we are keeping the temperature to 400 degrees Celsius. Now we have to say that the equilibrium mixture contains 27.5 gram of NH3, means at equilibrium the ammonia becomes 27.54 grams. So we have to calculate the Kc for the above reaction, whose unit will be mole raised to the power minus 2 liter square. The correct answer is B. We know that the reaction for this reaction equation for this given condition is nitrogen plus 3 moles of hydrogen giving us ammonia. So we are given that we have 56 gram of N2 and 6 gram of H2, and that thing is giving us 27.54 gram of ammonia at equilibrium. So if we consider that the initial mole of H2, so it will be 6 by 2, okay, that is 3 mole, and the initial number of moles of nitrogen will be 56 by 28. 28 is the molar mass and 56 is the given mass. That will also give 2 mole. So number of moles of hydrogen is 3 mole, number of moles of nitrogen is 2 mole. Now, if we write for the initial condition, then initially we don't have this ammonia. We have the nitrogen gas, which is 2 mole, and we have the hydrogen, which is 3 mole. So here we have ammonia as 0 mole. Now at equilibrium, some of the component will break down. So according to this equation, if X component of N2 is breaking, then it will require 3 components of this H2, therefore 3X. and that will produce 2 moles of this NH3. So it is 2x. So this will be the number of moles at equilibrium if x is the degree of dissociation. Now, for the ammonia, the equilibrium number of moles is given, which is what? Which is 2x is equals to 17.4, right? So accordingly, we have calculated this thing, right? Number of moles we have calculated 27.4 by 17, that is given us 1.62 at the number of moles of ammonia at equilibrium. Now we will equate this 2x with 1.62. So on equating, we get this equation. On further solving, we are getting it as x is equals to 0.81, right? So we got the value of x. So what will be the number of moles of N2? So it is 2 minus x at equilibrium. So x value is 0.81. That will give you 1.19. For H2, it will be 3 into 1 minus x or 3 minus 3x. Both are same. So 1 minus 0.81 into 3. So that is equals to 0.57. What is the equilibrium concentration then? For nitrogen, it will be 1.19 by 1. That is 1.19 m, because 1 liter was the volume of the container. So number of moles by volume of the solution, because the solution is spread over the whole container, right? It is gaseous in nature. So that will give us the concentration as 1.1 molar. For hydrogen, it will be the same, 0.57 by 1. That is 0.57 molar. Now what will be the concentration for ammonia? So it will be 1.62 by 1. That is 1.62 molar. So we got the concentration of each of the species at equilibrium. If we write the equilibrium constant again, then we get Kc is equals to NH3 whole square by N2 into H2 concentration cube. So that is 1.62 square by 1.19 into 0.57 cube, which is 11.9 mole raised to the power minus 2 liter square. Okay, you got the point? Okay. Next question. The concentration of CO2 will be, which will be in equilibrium with 2.5 into 10 to the power minus 2 mole per liter of CO at 100 degrees Celsius. For the reaction, FeO reacting with CO gaseous to give Fe plus CO2 gaseous. Kc is given as 5.0 will be how much? Options are A 0.5 into 10 to the power minus 1 mole per liter, B 1.25 into 10 to the power minus 1 mole per liter, C 2 into 10 to the power minus 2 mole per liter, and D none of this. So you have some time to solve this question. Your time starts now. Okay, your time is up. Now in this question, we are given that initially, suppose we have CO2, right, which is in equilibrium with this amount of CO. Okay. Now the reaction is also given, related reaction. We have to calculate the Kc. Oh, sorry, we have to calculate the concentration of CO2. Kc is 5.0. The correct answer will be B. So what will be Kc? It will be CO2 by CO. We are taking the gaseous species only. So that will be 5 is equals to CO2 by 2.5 into 10 to the power minus 2. Now you will ask that why we have not taken the FeO and FeS, because it is solid. We don't have a concentration. It is always unity for the solution, and for the gaseous phase we have. But for the solid phase, it is always 1 or unity, I would say. So Kc can be written in this way: 5 divided by 2.5 into 10 to the power minus 2. So that will give you CO2 concentration as 1.25 into 10 to the power minus 1 mole per liter. Clear? Okay. Next question. 1.1 moles of A are mixed with 2.2 moles of B, and mixture is kept in a 1 liter flask till the equilibrium A plus 2B giving us 2C plus D is reached. At equilibrium, 0.2 mole of C is formed. The equilibrium constant for the above reaction are A 0.0002, B 0.004, C 0.001, and D 0.003. So your time to solve this question starts now. So in this question, we are given that we are taking 1.1 mole of A and 2.2 mole of B, and we are mixing both of this and keeping it at 1 liter vessel, right? Till the equilibrium is reached. Now it is found that at equilibrium the number of moles of C is 0.2. So we have to calculate the equilibrium constant for the given reaction. Correct answer is C. Now we know that suppose we are considering A, small a, as the initial concentration of A, and for 2B it is small b. For C and D it will be 0 because we are not taking any moles of C or D. At equilibrium, what will happen? The number of moles, suppose X amounts of A has been broken, then accordingly 2X will be broken because 1 mole is reacting with 2 moles, so X mole will react with 2X mole. So that will accordingly give, according to the stoichiometric equation, it will give 2X moles of C and X moles of D. Now A value is given, we have taken 1.1 mole, it is given, B is 2.2, right? So what will be 2X? 2X will be 0.2 because it is also given that at equilibrium the concentration of C or the moles of C is 0.2. Now what will be Kc? So Kc will be 2x by 1 liter whole square. Why? Because 1 liter is the volume and 2x is the moles. So that will give you the number of moles of your what? C, and we're taking square because the stoichiometric coefficient is 2. Similarly for D it is x by 1 liter. For A it is A minus x by 1 liter. Okay, and for B it is B minus 2x by 1 liter. Of course we will take the square because again B has a stoichiometric coefficient of 2. If you put all the values, we know that this 2x is 4, right? This x is this 2 square is 4. This x square into x is x cube divided by a minus x, b minus 2x into whole square. And 1 liter is of course getting cancelled out. We don't have to worry about it. It is unity. So that will give you Kc is equals to this much. Now we know that 2x is equals to 0.2. Therefore x is equals to how much? 0.1. So we put the value of x here 0.1 cube. Accordingly, we know the value of A, it is 1.1. So we have kept it here 1.1 minus 0.1 because x value is 0.1. Now, if you put all these values accordingly, you will get Kc value as 0.001, which is your answer. Next question. In aqueous solution, the ionization constant for carbonic acid are K1 is equals to 4.2 into 10 to the power minus 7 and K2 is 4.8 into 10 to the power minus 11. Select the correct statement for a saturated 0.034 molar solution of the carbonic acid. Options are A. The concentration of CO3 2 minus is 0.034 molar. B. The concentration of CO3 2 minus is greater than that of HCO3 minus. The concentration of H plus and HCO3 minus are approximately equal. The concentration of H plus is double that of CO3 2 minus. So in this question, we are given that we are having an aqueous solution whose ionization constant for carbonic acid K1 is 4.2 into 10 to the power minus 7 and K2 is 4.8 into 10 to the power minus 11. We have to select the correct statement for saturated 0.034 solution of the carbonic acid. Okay. Correct answer will be C. So in this question, H2CO3 is giving us H plus and HCO3 minus, and K1 value is given. Okay, we are writing the given things first. And K2 is given for HCO3 minus converting to CO3 2 minus, it is 4.8 into 10 to the power minus 11. Now we know that K1 is clearly very much greater than K2. You can see the difference here, right? It is 10 to the power minus 7 into 10 to the power minus 11 order. So we can say that all major part of H plus is coming from the first equation. Okay, H2 is giving this second dissociation is giving very negligible amount of H plus as compared to the first dissociation. So we are taking the total concentration of H plus is equals to the concentration of H plus released from this first dissociation. So from first dissociation we can write this also. H plus concentration is equals to HCO3 minus concentration is the total concentration, right? Means This is dissociating at a very small amount. So we are taking this concentration. This one concentration equals to the overall concentration. Clear? Got the point? So the correct answer will be C. Next question. The standard Gibbs energy change at 300 Kelvin for the reaction 2A plus B plus C is 2494.2 joule. At a given time, the composition of the reaction mixture is 1 by 2 and B is 2 and C is 1 by 2. The reaction proceeds in the where R is 8.314 joule per Kelvin per mole and E is 2.718. It is given. So for forward direction, first option is forward direction because Q is greater than Kc. B, reverse direction because Q is greater than Kc. Forward direction because Q is less than Kc. And D is reverse direction because Q is less than Kc. This question is saying that we are given the Gibbs free energy change, which is 2494.2 joule. And also the composition of A is given, which is 1 by 2 and B is 2 and C is also 1 by 2. In the additional data, we are given R value and E value, exponential value. So the correct answer will be B. So if you know the delta G naught, which is 2494.2 joule, and the reaction is also given, so we can calculate first of all Q. So Q will be how much? B concentration, which is 2, C concentration 1 by 2, A concentration 1 by 2 whole square is equals to 4. So we got the Q. And using this equation and this equation, we can find the value of K, right? So we are putting all of this thing here. So ln4 value is ln4 300 8.314 R value and delta G naught is this much. So we will get the delta G value as 5951.90, which is a positive value. Also, we know that delta G is equals to RT ln Q by Kc. So if delta G is positive, that means your Q is greater than Kc. Therefore, the reaction is spontaneous in the reverse direction. Clear? Okay. Next question. For the reaction 2NO2 dissociating to 2 moles of NO and 1 mole of O2, the Kc value is 1.8 into 10 to the power minus 6 at 184 degrees Celsius and R value is 0.083 kilojoule per mole per Kelvin. When Kp and Kc are compared at 184 degrees Celsius, it is found to be, options are Kp is whether Kp is greater than or less than or equal to Kc depends upon the total gas pressure. B, Kp equal to Kc. C, Kp is less than Kc. And D, Kp is greater than Kc. So your time to solve this question starts now. Your time is up. In this question, we are given Kc value, and we are given the equation, right? And R value is also given. And at the same time, temperature is given. You have to calculate that what is the relation between Kp and Kc. Correct answer is D. So first we will write the equation, that is 2 moles of NO2 is giving us 2 moles of NO and 1 mole of O2. Kc value is 1.8 into 10 to the power minus 6 at 184 degrees Celsius, or we can say 457 Kelvin. R value is 0.0831 kilojoule per mole per Kelvin. Now Kp Kc relation is Kp equal to Kc RT raised to the power delta Ng. Delta Ng value will be how much? 2 plus 1 3, 2 plus 1 3 minus 2, that is 1. So Kp value will be how much? Kc multiplied by R multiplied by 2 raised to the power 1. Or we can write it as 6.8358 into 10 to the power minus 6. So we got the Kp value as this, which is of course greater than the Kc value. Hence we can say that Kp is greater than Kc. Next question. For the reaction, CO gaseous reacting with Cl2 gaseous is giving us COCl2. So you have to know the ratio of Kp and Kc. Your options are A 1 by RT, B RT, C root under RT, and D 1.0. So your time to solve this question starts now. Your time is up. Okay. The question is saying that we are given a reaction in which carbon monoxide is reacting with chlorine gas to give us COCl2. So using the equation, you have to find that what is the ratio of Kp to Kc. The correct answer is A. We know the relation between Kp and Kc. It is Kp is equals to Kc RT delta Ng. Okay, so this is our equation for the relation between Kp and Kc. Now, accordingly, we can write the equation also that your carbon monoxide is reacting with Cl2 to give us COCl2. Now, all the species are in the gaseous phase, so we don't have to worry about identifying the gaseous phase molecules. So first of all, we will calculate this delta Ng, which is number of gaseous product mole, which is 1, minus reactant mole, number of gaseous reactant mole, that is 2. 1 minus 2, that will give you minus 1. So we can put this value back in the first equation. So that will give us Kp is equals to Kc multiplied by RT raised to the power minus 1. Or we can write Kp by Kc equal to RT raised to the power minus 1, 1 by RT. So this is your correct answer, which is A. So this was all for today's class. Okay, so with this we have completed 8 questions. Thank you.